Hello viewers, welcome back to my channel. Today I'm considering a very interesting topic in chemistry, and that is chemical equilibrium. If you are new on this platform and you're yet to subscribe to my channel, please do so by pressing the subscribe button below this video. And you can also share, press the notification bell, comment and like my videos. Now, the topic we are treating today is chemical equilibrium. What is chemical equilibrium? And where does it take place? Chemical equilibrium actually is a reaction that takes place inside a chemical reaction. And the word equilibrium itself means a balance. So when there is a balance between a forward reaction and backward reaction, that is chemical equilibrium. And a very good example of a physical equilibrium that we use as an illustration is when playing with a seesaw. That's like a plank that is placed on a support, in which two children with equal weight are seated at the two edges. So in that case, now you see that there will be no movement again, because the plank and the weight of the children has balanced the two edges, and it is being supported at the center by an object. So in that case, when the seesaw, actually when there's an unequal weight, maybe the way a child has a lower weight compared to the other, you see that the plank on that side where the child with the lower weight is seated will go up, while the one with the heavier weight will come down. But when they have the same weight, we see that it will be balanced. So in that case, there's no changes again. It will just be as if the plank is on a standstill. So in that kind of thing, we call it a balanced seesaw. So we have physical equilibrium and we have chemical equilibrium. I've just explained the meaning of equilibrium. So if in a chemical equilibrium, actually when a chemical reaction is occurring, the forward reaction is usually preceded by formation of product. That is, when two materials are reacted together, they are called reactants. They will give products. So when the product is formed, the products may be entirely different from the reactants. And you will see this with color changes or liberation of gases or some other reactions appearing. And it is also possible in case we have a reversible reaction, like in this case. Look at this sign. This is a reversible reaction in which we have the forward reaction to yield nitrogen 2 oxide, and then this nitrogen 2 oxide also reacts back to give you the reactants. That is a forward and backward reaction, and that is what is a reversible reaction. So in a chemical equilibrium, there is no observable changes in the product or reactant with respect to time. So a chemical equilibrium reaction occurs when there is no observable changes in the backward or forward reaction with respect to time. That is, as the reactants are reacting to form products, the products are reacting to form back the reactant, and then there's nothing is escaping. So actually a chemical equilibrium occurs in a closed system. Now, a very good example here is a reaction between sulfur 4 oxide and oxygen to give sulfur 6 oxide. And sulfur 6 oxide is reacting back or dissociating back to give you sulfur 4 oxide and oxygen. And this reaction is actually an exothermic reaction. That is the heat of reaction. This is the heat of reaction, H. While the change in H, this delta H means heat of product minus heat of reactant. That is, the heat of product, remove the heat of reactant from you, get the change in heat is minus 395 kilojoule per mole. That is in form of an heat energy. So a chemical equilibrium occurs in a closed system, just like I said. And to back up this topic, I made videos on exothermic reaction and endothermic reaction. You can quickly revisit that to learn more and check their energy profile diagram. Now, because in an exothermic reaction, the heat is liberated and then it is denoted by a negative sign, while in an endothermic reaction, the heat of reaction is positive, that is, heat is absorbed. So before we move on, we need to understand something, and that is equilibrium constant. You will notice that anytime reactants react together, two reactants or even one reactant react to form products, that is a forward reaction. Actually, forward reaction increases what we call equilibrium constant, which is the ratio of the product and the reactant. Now, let's look at this reaction, for instance. I'm going to write the equilibrium constant for this reaction, and that is the product, which is in the forward reaction. The forward reaction here is leading to sulfur 6 oxide. The product is written as SO3. Now, bracket here means concentration. That is the concentration of the product. This is the number of mole. The number of mole is 2. Will be square raised to power 2. Assuming the number of mole is 3 to be raised to power 3. All over. Now, the number of mole of sulfur 4 oxide here. So, let's assume concentration of sulfur oxide is inside the bracket. Raised to power 2 multiplied by the number of, concentration of oxygen raised to power 1, because this here, nothing is here, and that is 1. So this is how to write equilibrium constant. Now, assuming the equilibrium constant in a reaction is the equilibrium constant in a reaction is positive or 1, it means that more products are produced. Why? Because if you have a greater yield of product on top, and then you have a lower yield of reactants down, by the time you had subtracted, let's assume the product is 50 and the reactant is 10, you get a positive value. But if you have a lower yield of product and then more yield of reactants, for instance now, assuming you have product as 10 and reactant as 50, you will get a value that is less than 1. So in that case, we say that forward reaction leads to, or more formation of product leads to increase in equilibrium constant, and vice versa. So that leads us to a principle that needs to be learned in before we can understand the factors affecting chemical Le Chatelier's principle. Now, what are the factors that affect chemical equilibrium? The factors affecting chemical equilibrium are temperature, pressure, and concentration. This is unlike a rate of chemical reaction, in which we have about 6 factors: temperature, pressure, concentration, sunlight, surface area, and so on and so forth. Now, but in this case, we have just 3 factors. Catalyst is not one of them. Under rate of reaction, we also have catalyst as one of the factors. But in this case, we have just 3 factors. And for us to understand this factor, especially that of temperature, if you are given a chemical reaction and you're asked to describe the effect of increasing temperature or pressure of such reaction, what does it really mean? What's the importance or implication? Now, when a reaction is at equilibrium, it could even occur in the industry. The forward reaction will be equal to the backward reaction. There will be no changes. In a closed system, where as the product is being formed, none of them is escaping, and they are forming back reactants, especially in a reversible reaction. In such kind of cases, there will be no changes with time. So the best thing is to alter the conditions that affect such reactions. And so that we use the principle of Le Chatelier's to understand the effect of each of these factors. When we alter each of these factors, how will they affect the system, favor or not favor the system? So the first one here is Le Chatelier's principle, and it states that when a reaction is at equilibrium, that is, the rate of the forward reaction is equal to the rate of the backward reaction, and an external constraints like pressure, concentration, and temperature is added to the reaction or imposed on the reaction at equilibrium, the reaction will adjust itself in order to neutralize or disannul the effects. That is, when a reaction is going on in equilibrium, there's no changes, both forward reaction and backward reaction are occurring, and there are no changes, nothing is escaping, the reaction is not stopping. In that case, if you try to impose a factor, an external constraint, like changes in temperature, whether increase or decrease, changes in pressure, increase or decrease, or concentration, when we do any of this, the reaction will quickly adjust itself in order to neutralize this effect. So let's look at the first factor, which is the effect of temperature. Now, if you want to answer any question on that effect of temperature, you must be given the reaction, and you may be given the reaction, but the most important thing that you cannot do without is whether the reaction is exothermic or endothermic. I've made a video on that. You can quickly check the videos on exothermic and endothermic reaction. So you can see this equation of reaction, say the heat change at the end, which is positive, showing that it is an endothermic reaction. And you also need to understand how to draw the energy profile diagram. I've made a video on this as well, well explained video on that. If you look at this reaction, the heat of reaction is negative. That is an exothermic reaction. So the first thing to do when you want to answer a question on temperature, how does temperature affect chemical equilibrium? The question will be in this form. State the effect of increase in temperature on the following reaction. How will increase in temperature affect this reaction? Now, we will use Le Chatelier's principle to explain this. But the first thing you need to look at is, just like I said, the heat of reaction here is positive. That is endothermic reaction. And you will quickly sketch an endothermic reaction. That is what I'm doing now. At the beginning, heat is low. At the end, heat is higher because heat has been absorbed at the end. So you can see low heat, high heat. At the beginning, low heat. At the end, heat has been absorbed. So for these reactants to react to form this product, it requires low heat. For the forward reaction, you can see that this is a reversible reaction sign. That is, nitrogen reacts with oxygen to give you 2 moles of nitrogen 2 oxide. And then nitrogen 2 oxide, this is a backward reaction, also reacts or dissociates to yield nitrogen and oxygen back. That is a backward reaction. So for the forward reaction to lead to nitrogen 2 oxide, low temperature, which is here, you can see the level, is required. That is, from what I drew here, the level of temperature is lower compared to this level. Let me draw it well. Compare this with this. So at the beginning, low temperature is required. Now, for the backward reaction to form reactant back, high temperature is required. Now, if the question now is, what is the effect of increasing the temperature in a chemical equilibrium or in this reaction? What you will do is this. According to, that's the way you will state it, according to Le Chatelier's principle, the reaction will adjust itself in order to decrease the temperature back. You have increased the temperature of the reaction that was at equilibrium. You increase the temperature. So it's just like trying to bring the body back to the normal position. If there is heat, for instance, and you have to switch on the fan and blow yourself and then ensure that there's cross ventilation in order to bring the body back to normal and avoid sweating. So anytime there is a change in the body or there is a change in a system, the system will adjust in order to bring it back to normal. So when there is an increase in temperature, the reaction will adjust itself to reduce the temperature, and that is what will happen. That's what Le Chatelier's principle explains, that when a reaction is at equilibrium and an external constraint is imposed on the system, that is change in temperature, pressure, or concentration, the reaction will adjust itself in order to disannul or neutralize this effect. So in this case now, the question is, what is the effect of increasing temperature? I have just looked at the heat of reaction that is endothermic, and I've sketched the energy profile diagram. You don't need to draw this when you're answering the question, just to know where you have high heat and low heat. So at the beginning, for forward reaction to form products, low heat is required because in an endothermic reaction, it is absorbed. So at the beginning, it was low. So at the end, more heat was absorbed. And so we have high heat at the end. And for the backward reaction of this reaction to form reactant back, we have high heat for such reaction. So what we'll do is this. What is the effect of increasing the temperature? According to Le Chatelier's principle, the reaction will adjust itself in order to decrease the temperature. Now, which side needs decrease in temperature? that's low temperature, is this reactant start that will yield what? Product. That is, this reactant part yielding product. That's a forward reaction, favoring the forward reaction. So equilibrium shifts to where? Now, what is this side? This is the left side, where more products are produced. That is, so according, the question is, what is the effect of increasing temperature? According to Le Chatelier's principle, the reaction will adjust itself in order to disannul the effect. It will adjust itself in order to decrease the temperature, favoring forward reaction. And anytime forward reaction is favored, forward reaction always leads to more product formation. And I told you that equilibrium constant increases anytime more products are produced. So equilibrium shift to the left, more products are formed, and forward reaction is being favored. Now let's look at the effect of temperature on this reaction again. Or what I will do is I'm going to give you as a classwork, what is the effect of decreasing the temperature of this reaction. Now, this is an exothermic reaction. You can quickly answer this question while I work it out as well. You can sketch your energy profile diagram. Look at the endothermic reaction. It is negative. So it means that there was high heat at the beginning, and at the end, the heat was released to the environment. So the container will be hot. So at the beginning, we have high heat. At the end, heat is released. So this is an exothermic reaction. So at the beginning of this reaction, we have high heat, which is required for forward reaction. So for the backward reaction, for this product to form back reactants, low heat is required. So the question is, what is the effect of decreasing the temperature? According to Le Chatelier's principle, the reaction will adjust itself in order to increase the temperature. Which side needs high temperature? This side, for forward reaction. So if I ask you, what is the effect of increasing the temperature? According to Le Chatelier's principle, the reaction will adjust itself in order to decrease the temperature. Which side needs low temperature? The product side, to form back reactants. So more reactants will be produced in that case, because this is for the forward reaction. Sulfur 4 oxide plus oxygen leads to sulfur 6 oxide. That's a forward reaction, and high heat is required based on the energy profile diagram of an exothermic reaction, in which we have high heat at the beginning, and then heat is released at the end, and the container is hot. So high heat at the beginning for forward reaction, low heat at the end for backward reaction. So in that case, now equilibrium is shifting back to the right, and more reactants are produced. And what's the overall effect of the equilibrium constant? It decreases. Now let's look at the effect of pressure. Now for the effect of pressure, let me reduce the clumsiness here. Now there are some conditions for pressure to affect a chemical equilibrium. Number one, the reaction must be in gaseous form. Number two, the total number of mole of the gaseous substance on the product side and the reactant side must not be equal. They must not be equal. So if they are equal, pressure will have no effect. And in this case now, let's look at the reaction. I told you that at least one of the reactants and the products must be in gaseous form. So pressure only affects gases. Now, in this reaction, let's look. We have iron, three atoms of iron with 4 moles of water in gaseous form. That is steam. That's adding steam to red hot iron to produce iron 3 oxide or iron 3 triiron oxide, and hydrogen gas is also liberated. So in this case, the only medium that is in gaseous form is water, and hydrogen, while others are in solid form. So let's look at the number of mole of water and hydrogen that are in gaseous form. They are equal. So pressure has no effect. Now let's look at this equation. The second equation here. We can see here that on the reactant side, the number of mole is just 1. On the product side, the number of mole is 2. And let's check the state of the reaction. That's why it's important when you are writing chemical equation to write the state of the reaction. So in this case now, they are both in gaseous form. So number 1, pressure will affect the reaction, provided the total number of mole on both sides are not equal. And they are not equal. This is 1, this is 2. So how do we look at the effect of pressure? When you increase the pressure of a reaction, in this case now, in this reaction, equation 2, when you increase the pressure, for instance, what is the effect? According to Le Chatelier's principle, the reaction will adjust itself to reduce. When you increase the pressure, that's the question, what will be the effect? According to Le Chatelier's principle, the reaction will adjust itself to reduce the pressure. Now, which side has lower number of mole? The side with the lower number of mole will be favored, and that is what will be produced. Low pressure for low number of mole, high pressure for higher number of mole. So what is the effect of increasing pressure? According to Le Chatelier's principle, the reaction will adjust itself in order to decrease the pressure. And which side is favored? More reactants are formed because the total number of mole here is just 1, and there is decrease in pressure. Now, if I ask you that, what is the effect of decreasing the pressure? According to Le Chatelier's principle, the reaction will adjust itself in order to increase the pressure. Which side has a greater number of mole? This product side. That is what will be formed. In that case, forward reaction is favored. More products are formed and equilibrium constant is increasing. Now, let's look at the effect of concentration. For concentration, the question will be asked in this form. What will be the effect of reducing the concentration of the calcium triazocarbonate 4? Or of increasing the concentration of calcium triazocarbonate 4. If you increase the concentration of a reactant, for instance, what will happen is that if you reduce the concentration, more products will be formed because all the calcium triazocarbonate will form calcium oxide and oxygen, provided it's in a closed container and none of them is escaping. You will now notice that because it's a reversible reaction, the products are forming back reactants. So what is the effect of increasing the concentration of calcium triazocarbonate? If you increase it, according to Le Chatelier's principle, the reaction will adjust itself to decrease the concentration. So in that case, as the concentration is being decreased, more of this is appearing, more products are appearing. So, and vice versa. What if one of the products is removed, like carbon dioxide? If it is removed or allowed to escape, what will happen? The concentration of the reactants will reduce because no products will form back reactants. That is how we talk about even if any of the reactants is being removed, it will affect. So if any of the products is being removed, there will be nothing to form reactants back, and so all the reactants will be used up, and it means that the concentration of the reactants is decreasing. And this is how we have treat questions on concentration. And catalyst has no effect on chemical equilibrium. It has effect on rate of chemical reaction. What does a catalyst do? It reduces the energy barrier in a chemical reaction by making it possible for reaction to occur easily by reducing the energy barrier, but it has no effect on chemical equilibrium. Watch out for other videos on this channel. I'm going to make a video on electrolysis, solubility, acid-base salts, pH calculation, and so on, and some gas law calculations. So I want you to watch out for this. If you are yet to subscribe, please do so. Don't forget to do that by subscribing, pressing the subscribe button below this video, and share my video, like my video, comment, and press the notification bell. Thank you.